Solving circuits, find all unknowns, example 2. So here's another mixed circuit here where we have some things in series, some things in parallel, and we're going to again want to find all of the unknowns here. So remember that we need to use Kirchhoff's laws, which tells us that any loop will give us add up to 0 in terms of the voltage, and that the charge is conserved so that if some goes this way, the rest goes that way, but we don't add or subtract off any of the current from the total. So whatever's coming out of the battery has to come back into the battery, although it'll divide itself up as appropriate based on the setup of the circuit. And we also need to remember Ohm's law, which is V equals IR. That one we'll use multiple times. So to start these, I always like to look and see, is there something easy I can do just to begin with to start unlocking some of this? Because the more you unlock, the more easier it becomes to unlock things, and the easier it is to check your work. See, oh, there's 2 ways to do that. Did I get the same answer both ways? And things like that. So when I look at this, I see I have my 3 resistors. I know the values, so I could find the total here, which is some work, but I could certainly do it. But I always like to start with something easy. And so when I look at this, something jumps out at me in that this path here is coming from the battery, and then I go around this loop. There's only 1 resistor in there, which means that if Kirchhoff's law says that all the voltage has to be 0 when it gets back here, this plus this must add up to 0. What's being given out has to be used in a loop. This tells me then that this has to be the full 5 volts, because it's the only thing that current is going through. So for number 1, V1 equals VO in this case, which is 5 volts. So that was really easy, no math to do. I just had to look at the circuit to do that. And then I say, okay, great. You know what's easier than adding up fractions and things like that for my total resistance? It's easier to just use Ohm's law again to find I1 here, which will be V1 over R1, which is, 5 volts over 40 ohms, which gives me 0.125 amps. So 0.125 amps there, and that whole section of the circuit has now been solved for. So you think, well, can I use either of these 2 things to tell me anything else about this? And the answer, unfortunately, is no. We know that I.O. is going to be bigger than 0.125 because something has to go through here, but we don't know how much. And the voltage, there's going to be 5 volts, yes, in this whole loop, but we don't know how much of the 5 this one will use and that one will use because they're different from each other. Those are 2 different resistors, and so it's going to be different. The higher resistance will use more voltage here, but I don't know how much. So the only thing I can do now is find the total resistance. So I'm going to look at this and say I have to add these 2 things up in parallel, but because these are in series, I can make an equivalent resistor between those 2 by simply adding the 2 values up. So that is nice and easy. Actually, when resistors are in series, you simply add them together, and we get 40 ohms for this branch of the circuit, which is really nice because when you put those 2 things together, you get the equivalent of 40 ohms, but this resistor here was 40 ohms, and so each branch has the same total resistance, which is really nice because that's going to, you'll see some symmetry here with some of the answers that we get. But we're not done finding the total resistance here because we now need to add these 2 up in parallel, which nobody likes to do, but I get 1 over R1 here, which was 40 ohms, plus 1 over the total resistance in that branch, which was also 40 ohms, really nice, 2 over 40, which gives our 1 over RT is 2 over 40. Cross multiply that, and we get the total resistance is 40 over 20, which is, or 40 over 2, sorry, which is 20 ohms. Nice and easy. And from that, I can now find the current flowing out of this battery, using Ohm's law again, it'll be VO over the total resistance in this circuit, which was 5 volts divided by 20 ohms, which is 0.25 amps. So I can put that in 0.25 amps, which means then, and you'll see how this is nice, 125 is half of 0.25, and so which means then that half the current went down this branch and the other half went down this way. So I can find that by saying, okay, since there's only 2 branches, if there was 3 branches, that would further divide. But I can say then that my current out of the battery minus the current that flowed down this branch here gives me 0.25 amps. And remember in series that the amperage is the same. It's the same current that flows through both. And so we have this here. And this is where it being 40, a total resistance of 40 in that branch, and this also being 40, that's why the current is the same. That's not always the case. Had this added up to say 60 or something else, then it wouldn't have been equal like this. But this is nice because this gives us 2 answers for the price of 1. So we have both of those, and now you can see we're almost done. We just need to use Ohm's law 2 more times here to find the voltage. And we do know that this voltage is going to add up to 5, because that's the total from the battery. And so if I find one of these, I should be able to find the other 2 ways. So let's do V2 first, again, only because it comes first, 2 before 3, as I did in the last example. But you could do V3 if you wanted, and we get 0.125 amps times 10 ohms, which is 1.25 volts. So 1.25 volts goes there. And so that should tell you then what the voltage is here. If this loop has to add up to 5, well, 1.5 plus, or 1.25 plus 3.75 would equal 5 volts in total. So that's how you use Kirchhoff's laws to solve these things. But just to check, double check, you should always double check these things when you can. Does the values I have for I and R work out? And we get 0.125 amps times 30 ohms, which, yes, indeed, equals 3.75 volts. So perfect. We are pretty sure we've done this correctly when we get the same answer using 2 different methods. So that's how you solve a mixed circuit. Remember, they're always different from one another. It's not like if you solved yesterday's crossword puzzle, then you're for sure going to be able to solve tomorrow's crossword puzzle. They're all different. They take a lot of practice. So do lots of these.